In this lab, you will be learning about the properties of different kind of waves. So we are basically observing water wave, sound wave, and a light wave. The first two, the water wave and the sound waves, are mechanical waves. They can transfer from one part of space to the another part. They need some kind of medium, but light wave is electromagnetic wave, and it can move from one point of space to the another without any kind of medium in empty space. So that's the basic difference between mechanical wave and a light wave. So you get all kind of theoretical knowledge from textbook or lecture slides about these kind of waves. So let's directly move to the simulation link. Here it is. You can click on it and you will be heading to the simulation window. So the first thing we are observing is about the wave behavior of water. So once you click the link given above, you will be heading to this window, and this is the first option for water wave. And then click on the side right here. It's already clicked here, the top one, and then there is top view and the side view. Click on side view. It's better to observe side view for water wave. You can clearly see what is happening at the top of the water level when wave is passing through it. And then the normal mode is okay. We don't need to slow down. And then let me go back what we have to do. So set frequency to minimum and press green button to set the wave in the water surface. Observe what is happening with the wavelength. Then we will set in number B, we'll be setting frequency to maximum and observe wavelength again. So you will see what is happening when you set frequency to maximum and minimum. Okay, so let's go and do this activity. Frequency is right here. You can just hold and drag to set minimum. Right now it's a minimum. And once I click on this, this one, it should go. Nothing is happening when frequency is minimum. Amplitude is 0. That's why nothing is happening, right? Set frequency somewhere, because if you set frequency 0, that means wave is not passing, right? If you set frequency right here, frequency minimum and amplitude somewhere middle, uh, see the wave, how wave is passing through. Okay, just observe the pattern, how waves are generated and transmitting through the medium. The medium is water right now. Set this frequency to maximum and again click on, look at the wave. That is quite different kind of wave patterns, right? When you set frequency to minimum and frequency maximum, keeping amplitude somewhere at middle or somewhere other points, right? This is just for observation. And what happened to wavelength? Wavelength increases when frequency is minimum, right? Let me show you again. When it is minimum, the wavelength is length of a wave, right? Let's see here. Yes. So how long is this wave? It's starting from here to here. This is almost one wave, right? This length is, if you try to measure it, I can measure from here and here. This is 6.2 centimeter, right? If I set it maximum, let me check it again. Observe. Okay, let it go. And I would just like to get one wave so that you can see it easily. Okay, so I have another wave right now. The previous one, when frequency is minimum, the wavelength was 6.2. Measure this one again. The length of the wave, one wave means length from here to here, right? They complete one circle, one from the top and another half circle from the down. It will form one wave. So measuring from here, it is started to go up from this point, right? Uh, you can just hold and drag this way up to this point where this wave is getting back from down, right? Coming upwards to this is equilibrium line, dash line. So 1.7. See the difference, what happened? When you increase the frequency to maximum value, what happened? Wavelength decreased. So there is inverse relationship between frequency and the wavelength. If you increase one, other will decrease. If you decrease one, the other will increase, right? Vice versa. Opposite relationship that we call inverse relationship in mathematics, right? So we observed these two phenomena up to here. You can explain what had happened when you observe these two steps. Diona had sent me email about this part C. This is actually right. My previous statement was wrong. At top right, you can see a box having time along X and water level on Y-axis. Click and hold on it. So this statement is basically talking about this box. You can see the time along X-axis, this axis, and water level along Y-axis, and it can measure wave. So put it here. You can read the instruction. You have to put this one somewhere left from the center so that you can see the different wave patterns, passing through the first probe and the second probe, right? Slightly left and then let wave pass. What happens to amplitude of the wave? So you are basically absorbing amplitude of the wave, right? Either it should be increased or decreased while passing through the two probes. Okay, let's observe and see. Okay, so let me uh, is it saying something to set? Let me see the instruction. Bring this amplitude and a time measuring tool. There are two wires left. Water surface. Click on the green button. Okay. Observe amplitude of the, okay, you can set anywhere amplitude just for observation purpose. So let me set a wave simply here. Yeah. Okay. Anyway, let me set it right now. Okay. Okay, just one wave. Okay. So what happened? Do you observe any difference? So if you look at the two waves here, one wave, this is when passing through the first probe, this one, and the second one, the dark one, is the wave when passing through second probe, right? Actually, this is a single wave. When this wave is transmitting through the medium, that is water surface, there is difference. What do you observe? Look at here. The difference is amplitude, right? The amplitude is the distance from we are measuring vertical height right now, right? So this distance is actually amplitude, right? The maximum displacement from the um, equilibrium. So this is equilibrium line, the x-axis we can say right now. And then the maximum displacement from maximum is these stops, right? This stop down and this stop. Okay. So see here, 0.7 centimeter, right? So this is the wave, the second part, this dark part is the wave when passing through the second probe, the dark probe, the black one, right? And then you can measure here as well. So this is exactly 0.7 centimeter, right? So this is amplitude. Again, measure same thing, which is amplitude here, and measure it. It's 1 centimeter. 0.7 centimeter for the second one and 1 centimeter for the first one. What happened? Amplitude decreases as it passes through first to the second, right? The amplitude for the wave passing through the first probe is more than the second one. What happened? So, as energy passes, energy will be dissipated, right? There is some energy loss because of that. How waves are generated? Wave is kind of energy. So, as it passes through the medium, energy will disappear. There is energy loss, right? So, this is reasonable. The amplitude should be less than the first probe. Okay, so you measured it and you can now explain what is happening here, okay? Uh, I explained what happened to the amplitude of the wave, increase or decrease, and I also explained why, right? You can put in your own wording. So move on to the next. Now keeping amplitude and the frequency tap at maximum, both will be maximum. Generate a wave and measure wavelength by using yellow tape with blue button. Okay, so we are already measuring that. Let me use just one probe because we just need a wavelength. So keep it both maximum, right? That's what it is saying. Now keeping amplitude and frequency at max, generate a wave and measure wavelength by using alert. Okay, so our goal is measuring wavelength and the frequency. So this will be kind of rough data because, in simulation link, we don't have direct measurement, digitally measuring the wavelength and the wave. We are just using these tapes and time to measure frequency. So first, how to measure wavelength? Simply generate a wave. Click on here. Just wait. Let it go. Okay, I just need one wave. I don't make it crowd. So let me just drop one drop of water and then stop here. Okay, so let it go a little bit so that I can. Let me do it again, repeat it. Sometimes you have to repeat experiment if you are not getting what you need to get. Okay, let it pass and let me do it again. Okay, so this is perfect. Now, bring this measuring tape. Wavelength is starting, wave started to rise from this point, right? It ends at this point. This is measuring the single wave so that you can easily measure wavelength. So put your tape right here and then to here. So this is 0.9, okay? So 0.9 centimeter is wavelength. You can write it down somewhere here. Wavelength is 0.9. 0.9 centimeter, right? Okay, so frequency. Let me clear. I can't go back without clearing. clear try. Then okay. So that was wavelength. And then to measure frequency, see here how you can measure frequency. What is the relationship between frequency and the time? So there is inverse relationship, right? The frequency f is equal to 1 divided by t, capital T, the time, the period. What is period? The period is to complete one oscillation. So one oscillation means one wave. So see here, this is one wave, right? It's starting from here to ending at this point. So the time taken to complete this one is called period. That is time t. So measure that period, then you can find the frequency. Okay. So see here, this is almost restarting. So as I said, we'll be just taking the rough estimate of the time. This is 1 second, right? See, it's set here, 1 second. So these boxes are 1 second. So almost 1 second, but we can say almost 1.1 second, right? Little bit more. It started from right behind this line and then goes up to here. So it's a tentatively 1.1. So uh, you have time. So you have time. Your time and capital T. This is the period. Period is 1.1 second. I think wavelength was 0.9 centimeter, right? So you can convert in meter to get SI unit. This must second, right? How to find the frequency? Frequency F. So this frequency F will be 1 divided by 1.1. Okay, so you can easily divide 1 by 1.1 and you will be getting frequency. You can put it into calculator and get the actual value of frequency, right? Once you have wavelength and the frequency, so please convert this one into meter because your unit should be consistent. Centimeter is not SI unit, convert it into meter, and the time is in seconds. So second is SI unit. That is a standard unit. So velocity will be wavelength. Simply put value, this value, whatever you have here, and then frequency, what do you get it from here, right here, right? So you will be getting velocity. This value will be quite low because the water wave is traveling with the small velocity, right? Velocity is not huge. Okay, so this step is completed. Now go down, click on top view and explain what you observe. This is just for observation purpose. Uh, click on top view. Top view is right here, and just to see what is happening when it happened. When you are looking water wave from the top, you will observe something like this, right? You can't see something like this. This is a side view. Side view is very beautiful view when you are observing water waves. These are making some kind of ranges, right? Hills. Okay, so the first part is almost done, I think. And going to the next, now click on the sound wave and observe again. So click on play tone, graph, and both. Click on green button to make a sound. Then set frequency minimum and then maximum and see the difference. Okay, so that's second part sound. I'm clicking on both the wave and the particles. Play graph is already set there. Frequency minimum. Let me create a wave. Okay. If I set this frequency maximum, what is the difference? See here, from this experiment, you understand why piece of the sound is different. Very basic physics of the sound wave, right? The sound, the sound coming from the vocal cord of women and men are quite different. You understand why? How frequency affects uh, tone or piece of the sound intensity, right? When frequency is maximum, minimum, or frequency and wavelength are main player. So you can write down your answer here once you observe this observation. So observe the medium particles. How do you explain nature of movements of medium particles when wave is passing through it and when it is not? Right now, I can click on both particles and waves. You can see particle as well as wave pattern. In general, we can't see when we are speaking. This is sound wave, right? But you don't see any kind of pattern creating in the environment, right? Actually, this is uh, happening when we are speaking or creating any kind of sound wave. Let me see. So this one, right? Uh, no. Okay. So right now there is no sound wave generating. The uh, air molecules are always vibrating. They are spacing something randomly like this, right? When a wave is not generated, if you create a wave, the sound wave, and you look at here, just look at the nature. What is happening? They are forming certain kind of pattern, right? See here some points. The particles are compressing. At some other points, there is less density of particles that we call rarefaction. The compression and the rarefaction patterns will be generated. Okay, so this is our observation and write it down there. Click on light button so you are done with the sound wave. Let us go to the light wave. The light wave is will be more abstract because frequency is very high and wavelength is very shorter. uh, Going into this measure wavelength uh, and the frequency. Okay, so that's our goal. So light here, and then you are measuring wavelength and the frequency of different colored light. So I'm demonstrating for just one first part. He will be doing rest of them. Here, post for red light. Later on, similarly, you can find the velocity of green, blue, and violet lights. You can do by yourself. You just have to change the position. I mean position right here, right? You can set any here. If you need for green light, set it here. If you need for violet, set it somewhere violet. This is blue, right? So blue somewhere here. I need for red. So I will be setting somewhere middle of this red portion. So I have graph, clicked on the graph, gray screen and the sound effect, everything is here. And then I can observe all these phenomena, what is happening with this one. Okay, sounds wave, graph. Okay, okay, let me see. Okay, Web is gone. Okay, so I just need wavelength. Wave length of one wave. Okay, so I generated a wave and I would like to measure wave somewhere, any point. Let me just measure a first one, right? Starting from here, this is in nanometer. When we come to the light wave measuring wavelength, this is really very small, right? So that's why a nanometer. What is nanometer? 10 power negative 9. 1 meter is equivalent to 10 power negative 9 meter. Neg I mean, if it is nanometer, 600, you have to multiply this one by 10 power negative 9 to get nanometer. Okay, a meter, I mean, sorry. Okay, so here, right, is 651.2 nanometer. Write it down, wavelength of wave 651. 1.2 nanometer. So you have to convert this one into meter by simply multiplying 10 power negative 9. Now it becomes in meter, right? We need in SI system. So Google frequency of red light and find the velocity of red light by using this formula. Same formula as we did for water. Let me go back, clear it. It's 600. So let us Google frequency of red light. Okay. It's in hertz. We don't. Trillion hertz. What is the trillion means? 10 power, how many zeros? 10 power 12, right? So 10 power 12 zeros. 4.3 times 10 power 14 hertz. That is the meaning of trillion, right? Let us go down here. And your frequency for red light is 4.3 times 10 power 14, right? 14 what? Hertz. Hertz is SI unit. So this is correct. And you already have this one, as I remember. You can check it again if this is wrong. I think that's what we get, right? 2 times 10 power negative 9. Negative 9, right? So if I put this decimal right here instead of here, I can erase this one. So this will become 7, right? This will become 7. So now multiply this value with this value to get velocity. So this decimal 0.77, this is 10 to the power 7 positive, right? When you multiply this one, 6 7, 2.8. It's coming tentatively. You can put into calculator, but I am getting something like 2.8 into 10 power 8 meter per second. So we are getting reasonable value, right? Because the actual value of velocity of light is nearly 3 times 10 power 8. We are very close to the um, actual value of velocity of light. If you are getting something different from by measuring wavelength and the frequency of light wave, so you are doing wrong, right? Your velocity should be very closer to this one. Actual value is 3 times 10 power 8. Okay. Hope you understand this lab. If you have any question, just send to me.